Assalamu alaikum, dear students. Today our topic is again trends in properties of D block elements. And today's properties which we have to discuss are oxidation state. Number second is catalytic properties. And number third is ionic compounds. So we will discuss today first the oxidation state. One of the characteristic property of the transition elements is that they show variable or several oxidation state. If we take the first transition series, that is 3D series, except few elements, most of the elements show several oxidation states, and these oxidation states are related to their electronic configuration. It is very important. Oxidation states are related to their electronic configuration. इलेक्ट्रॉनिक कन्फिग्रेशन से ही हम एक पर्टिकुलर ट्रांजिशन एलिमेंट का ऑक्सीडेशन स्टेट डिटरमाइन कर सकते हैं. लेट्स टेक द फर्स्ट 3D transition series and write the oxidation state of the elements, that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. 21, 22, 23, 24, 5, 6, 7, 8, 29, 30. This is 3D series, and we have the first element, that is scandium, and we will now write their oxidation state. It is +2, +2, +2, +2, +2, +2, +2, +2, +2. It also possesses +1. Scandium does not show +2 oxidation state. Then we have +3, +3, +3, +3, +3, +3. Again we have +4, +4, +4, +4, +4, +4, +4, +5, +5, +5, +5, +6, +6, +6, and +7. The oxidation state of the elements is due to the presence of the electrons in the ns and n-1d orbitals. The +2 oxidation state is the oxidation state is shown by the bonding of the electrons in the ns and n-1d orbitals. The +2 oxidation state is exhibited by the involvement of the electrons which are present in the ns orbital, by the bonding of the electrons present in the ns orbital only, whereas the higher oxidation state is exhibited by the bonding of both ns and n-1d electrons in the bonding. From the above, if we see that, we can conclude that the stability of the compound in a particular oxidation state that depends upon the nature of the element with which the transition element with which this particular element forms the compound. That is +2, if we also conclude from this oxidation state that +2 oxidation state is the most common oxidation state, and the elements that form +2 and +3 oxidation state, they generally form ionic bonds, whereas the compounds in the higher oxidation states form the ionic bonds and the rest form the covalent bonds. The oxidation state of the element increases as the atomic number increases. It reaches a maximum value at the center, that is +7, and then again it decreases. And the maximum oxidations shown by any element in this 3D transition series is +7. So these were some important points regarding the oxidation state. Now our second one is catalytic property. Catalytic properties. Various transition elements and their compounds act as catalysts. For example, vanadium in V2O5 acts as catalyst in the manufacture of sulfuric acid, by contact process. Number second, cobalt as cobalt thorium in Fischer-Tropsch process in the synthesis of gasoline, petrol. Nickel in finely powdered state in the hydrogenation of oils and fats. Iron in the synthesis or manufacture of ammonia by Haber's process. Also platinum in the synthesis of sulfuric acid by contact process, and in the conversion of ammonia into nitric acid by Ostwald process. Now, why these act as catalysts? The reason for these elements or their compounds to act as the catalyst is due to the presence of unpaired electrons in the d orbitals. Due to which they absorb the energy and then re-emit the same energy and due to which they provide the necessary activation energy. This is one reason. The second reason is that these catalysts reacting with one of the reacting elements, these catalysts or the transition elements or their compounds, they react with one of the transition element, they form intermediate compound which provide a separate path with lower activation energy and then this intermediate compound gets decomposed when it reacts with the second element and then it regenerates the catalyst. For example, if we take X and plus catalyst, it forms X catalyst. This X catalyst with Y, it forms XY plus catalyst. For example, in the combination of the sulfur dioxide with the oxygen to form the sulfur trioxide, vanadium pentoxide is used as a catalyst, and how this catalyst plays its role in reacting the sulfur dioxide and oxygen to form the sulfur trioxide. Sulfur dioxide reacts with vanadium pentoxide and it forms V2O4 plus SO3. This is divanadium. Tetraoxide, and this vanadium tetraoxide then reacts with the another reactant, that is the oxygen. It regenerates V2O5, vanadium pentoxide, but the product formed is sulfur trioxide. This is the role of the catalyst. And our next property is ionic compounds. One more characteristic of the transition elements is that transition element compounds, both transition element compounds, both ionic as well as कोवलेंट, तो वो कंपाउंड जिनमें ट्रांजिशन एलिमेंट हो, most of these transition element compounds which are either ionic or the covalent, either in solid state or in aqueous state, they act as ionic compounds in contrast to the elements formed by the S and P block elements. Now, what is the reason that these form the ionic compounds? The transition element compounds, whether they are, चाहे वो ionic हो, चाहे वो covalent हो, चाहे वो solid state में हो, चाहे वो aqueous solution में हो, they act as, most of these compounds, various compounds in such form act as colored compounds. Now, what is the reason? It is because of the incomplete, unpaired d subshell electrons present in these elements, transition elements. For example, we have d orbital, this is the orbitals of d subshell, and when a ligand or and any species approach to the end, ligand or any ion approach these catalysts to form the compound, the d orbitals, they get split into the two set of orbitals. That means they no longer remain as degenerate. Degenerate means the orbitals of the same energy. So they get split into two set of orbitals. That is, one is these are called T2G orbitals. This is dxy, dyz, dzx, and this is Eg orbital, dx square minus y square, dz square. Now, the electrons from, this is of lower energy and this is of higher energy. The electrons that are present in the lower energy orbitals, they absorb the energy and they get excited to the orbital T2G, Eg orbitals within the same d subshell. Now, where from they get the energy? They absorb the energy from the radiation of the visible light. This radiation of light of particular wavelength. तो ये विजिबल लाइट के रेडिएशन जो हैं ऑफ पर्टिकुलर वेवलेंथ, उनको एब्जॉर्ब करके ये इलेक्ट्रॉन शिफ्ट होते हैं, एक्साइट होते हैं टू द हायर एनर्जी लेवल. अब जो ये रेडिएशन एब्जॉर्ब करते हैं, in the visible light, they belong to the light of a light which have the particular wavelength. ये correspond करती है light color की जो इस रेडिएशन की वेवलेंथ में है, कलर में है और इस विजिबल लाइट में है. फॉर एग्जाम्पल, द इलेक्ट्रॉन, one or two electron from this T2G orbitals, they absorb the radiation which corresponding to the wavelength of the red light, and they get then excited. They emit the radiation which correspond to the color of rest of the radiation is present in the white light. That is, अगर ये रेड लाइट की रेडिएशन वेवलेंथ रेडिएशन की, if they absorb the radiation which are of wavelength corresponding to the red light, they emit the rest radiations which are complementary to the red light. That means they emit the greenish blue light. Because ये जो रेड लाइट की रेडिएशन ऑफ रेड लाइट वेवलेंथ की रेडिएशन एब्जॉर्ब की और बाकी रेडिएशन उन्होंने इमिट की इन द फॉर्म ऑफ द कलर, तो वो बाकी जो सारे कलर्स मिला के उनकी रेडिएशन की वेवलेंथ होती है वो मिला के ये इमिट करता है, ट्रांसमिट करता है. तो उनका कंबाइन होके कलर जो बनता है दैट बिकम्स ग्रीनिश ब्लू which is complementary to the red light. Now, what do you mean by complementary? Complementary means when we combine the greenish blue light with the red light, they form again the white light. They again form the white light, so these are complementary to each other. Now, if the electrons emit the radiation of particular wavelength that is of blue, they transmit the color, the light of the wavelength which correspond to color which is complementary to the blue color. So in this way, this is the property due to which they show their compounds are generally ionic compounds are generally colorless.